All right, can you see the screen? Think we can
Yes,
start
can.
now. Okay, I think we can start now. All right, so last week we discussed chapter 6, which is on probability. So today we will discuss on chapter 7, which is discrete probability distribution. Yeah. So this is an overview of what is inside this chapter. So first we're going to look into the random variables, and then followed by binomial problem distributions, and also how to calculate the mean, variance, and standard deviation for binomial distributions. And then lastly, we will talk about Poisson probability distributions. Yeah. So the key concept of random variables. So the concept of random variables, how they relate to the probability distribution. So after this, we're going to look into probability distribution. How does the probability distributions looks like and what is it about? And then we also will distinguish between discrete random variables and continuous random variables. Okay. And we will look into the formulas to find the mean, variance, and standard deviations for probability distributions. Yeah. And then we will look into on how to determine whether an outcomes are likely to occur by chance or are they unusual. So we want to see whether the outcomes is within the usual range or outside the usual range. Okay, these are the things that we're gonna look into. Okay, probability distributions. Yeah. So what is random variables? It is a variable that has a single numerical value determined by chance for each outcome of a procedure. Yeah. And the probability distribution is a description that gives the probability for each value of the random variables, often expressed as in the format of graph, table, and formula. Okay, we look into it in. Okay, look at this discrete random variable. So discrete random variable is a finite number of values or countable numbers of values, where countable refers to the fact there might be infinitely many values, but the result from a counting process. For example, the discrete random variable. For example, the number of people now driving car in a Kuching. Contohlah, ada dua, 100 cars in Kuching, 1,000 cars in Kuching, the number of houses in certain block, the number of fish caught on a fishing trip, and the number of complaints received in office of an airline or on a given day. So discrete is something that is memang satu. There's value for it. There's a countable values for it. That is a discrete numbers. Where when compared to the continuous is usually when we talk about discrete is an exact value like 2, 3, 4, 5. Yeah, satu. Or but for continuous, it's in between range. For example, 2 to 5. So it's in between. Then you have a value of 2.5, 3.1, yeah, and 4.5. Yeah, that's continuous. Where you can draw it in terms of graph. Is continuous. Discrete is one by one lah. Okay. Okay, this is a continuous random variable. It's infinitely many values, and those values can be associated with measurements or continuous scale without gaps. Without gaps. For continuous, it must be without gaps or interruption. So for example, for continuous random variables, it is time required to fly from Kuching to Osaka. So for maybe around 6 hours. So around 4 p.m. to 10 p.m. Macam tu kan. The time taken to commute from home to work, so how many, maybe 40 minutes. Macam tu. The weight of a fish, so it can be in between, you know, how many kgs to many kgs, and the price of a house, so much range, the range of the house, the price of the house lah, that's continuous. Yeah. Okay, now the characteristic of discrete probability distributions. There is numerical random variable x and its values are associated with corresponding probabilities. Later on, I will show you how does the probability distributions table looks like. And I think when I show you the table, maybe it will be much clearer for you lah, right? So when we talk about probability, so it's similar. When we talk about the probability, the summation of probability must be equal to 1. So similar thing for probability distributions, the summation of the total probability distributions must be equal to 1. Yeah, the same concept as probability before this. And of course, the value for the probability must be in between 0 and 1. Sama kan macam probability last week. So the values for the probability must be in between 0 to 1. Yeah. Okay, we look at this example of discrete probability distributions. This is what we call a table of probability distributions. Yeah, this is the variable. Okay, this is the probability. Okay, the probability for the variables. Yeah, for the variables. Okay, let's look at this one. Let's consider a simple example that involve only 2 births. Okay, with following random variables. So our variable here is number of girls. Number of girls in two births. Okay, so number of girls in 2 births. So kita ada 2 births. What is the combinations of the birth? Either whether it's girl or boy macam tu lah. Alright, so x is a random variables because its numerical values depends on chance. Yeah, with 2 births, the number of girls can be, so it can be both boys, right? From 2 births, it can be both boy, and it can also be the first birth is boy and the second birth is girl. And also it can be first birth is girl and the second birth is boy. Or it can be girls and girls, correct? So the combinations. So now we know that the X is the number of girls in 2 births. Okay, the number of girls in 2 births. So it means that for the first one combinations, boy and boy, so it means that boy and boy there is no girls, so 0 girls. Okay, so this is X for when the situation when 2 births consists of 2 boys. So it means that there's 0 girls because X is the number of girls. As for the second one is when this happened, when 1 boy, 1 girl. So it means that BG or GB. So 1 girl. So X is 1. Yeah, because X is, remember that X is the number of girls. And for the last one is when you get 2 girls from 2 births. So it's GG. So that's why we have 2 girls here. That's why X is 0, 1, 2. And the probability given here is probability for getting no girls at all is 0.25. And probability for getting 1 girls in 2 births is 0.5. And probability for getting 2 girls in 2 births is 0.25. This is given to you. So this is what we call a probability distribution table. Okay, probability distribution table. Okay, table 1 is probability distribution because it gives the probability for each value and it satisfies the requirement listed earlier. Okay, as you can see, this is when you draw a graph out from the probability distribution. So how do you draw this graph is, you know, just this one is X and this one is your PX lah. Okay, X0, 1, 2. Okay. And also you have to bear in mind that for probability for this table to be called probability distribution table, the total of the probability the total of the probability have to be equal to 1. So in this case, it is 0.5 plus 0.25 plus 0.5, 0.25 plus 0.25, then so it is equal to 1. So if the probability, the summation of probability is equal to 1, then we can say this is a distribution, probability distribution table. Yeah. Okay, this is the graph just now. All right, so look at the second example. Senior executive for us to okay. Senior executive for us when job applicants should discuss salary, and table 2 is based on their responses. Okay, does table 2 describe probability of distributions? So when you look at this, you have the random variable, you have x, so x is 1, 2, 3, and px, so px is the probability. So we want to check whether this is this table describes probability distribution. So first we need to check whether the summation of px is equal to 1 or not. So 0.3 plus 0.2 plus 0.1 is equal to 1. 0.3
No.
plus 0.26. So it's not equal
No.
to 1. So we cannot say that this table describes probability distributions. Yeah, because it does not equal to 1. So this does not require does not satisfy the second requirement. So we can say that table 2 does not describe a probability distributions because the summation of the probability does not equal to 1. Yeah. All right. For discrete probability distributions, these are the formula for you to find the variance at the mean, the variance, and this is the shortcut for the variance and the standard deviations. Yeah. So these are the formula when you want to find the mean, variance, and standard deviation for discrete probability distributions. We're going to look into some of the example to calculate this. Okay, the round of rule for mean, sigma, and mean, standard deviations, and mean, standard deviations, and variance. So round result by carrying one more decimal place than the number of decimal place used for the random variable x. Okay, if the value of x are integers, round to one decimal. Contohlah x kan, we have probability like this kan. So if x is like 1, 2, 3, 4, so our mean have to be 1.2, for example. Say 1 means that one decimal place, and our standard deviations will be 0.5, for example. And you see, if its value is integers, so means there's no decimal numbers, so you just round to the one decimal place only. But if you have so it depends on the random variable x lah. Okay, so round result by carrying one more decimal place than the number of decimal place used in random x. Okay, it depends on random x. If it's if the random x is one decimal place, so your mean and your standard deviation and your variance will be 2 decimal place. Okay, dia mesti lebih satu decimal place from your random variable x. Yeah, that's only the rule for round off lah. All right, so now we want to try to find mean, variance, and standard deviation for the probability distributions. Okay, so you are given this probability distribution here, table here, from table 3, which is from previous example. So you want to calculate the mean, standard deviations, and the variance. Yeah. So what you need to do is the question gives you this table, right? So what you need to do is you just expand the table to this x times px, because you're going to need it in order for you to substitute into the formula. And you're going to need another one, which is x minus mu square times with px. Okay, so once you calculate this, you will be able to, you just need to substitute into the formula. You just need to you just take the formula from here. from here. So you just take the formula, then you get the answers. Yeah. So for the standard deviation, you have 0.704. You just substitute the value here, which is x squared plus x squared times square times with px. Maybe you can use the shortcut one. That one is the shortcut one. This is the not the variance, is the this one. So supposedly for this one, it's better for you to have another column which consists, you calculate square times with px. Yeah? So you calculate for each of it, and you just masukkan dalam your formula lah. Alright, then you calculate. And you look at this is another example. Base electronics manufactures computer parts that are supplied to many computer companies, despite the fact that two quality control inspectors at Base Electronic check every part of defects before it is shipped to another company. A few defective parts do pass through this inspection undetected. Let X denote be the number of X is the number of defective computer parts in shipment of 400. So the total of shipment is 400. The following table gives the probability of distribution for X. So X is the number of defective, yeah? So X is the number of defective. So 0 means 0 defective, 1 defective, and 5 defective of computer parts, yeah? And Px is our probability for getting the defective. For example, 0.3, this is the probability for getting 2 defective of a computer part, yeah? And compute the standard deviations of X. So compute the standard deviation. So what you need to do is, it's better for you to expand the probability distribution table. Yeah, expand the table so that you can get all the so that you can get all of this lah, all the values here, and you just need to substitute inside. Yeah, and so this is the original table. So you just expand it to this. Okay, so you calculate X times Px, and you calculate X squared, and you calculate X squared times Px. Yeah, so X squared times Px is 7.7. Okay, X times Px, this is the mu. This is the mean. X, the total, the summation of X times Px is the mean. So you just substitute inside here. So 2.5 squared. So you have your standard deviations equal to 1.204. Okay. All right, and then please bear in mind, usually like for this one, you have you round it to 2 decimal place because of this, right? But usually for the standard deviation itself, you put it in 3 decimal place. Yeah, always not less than 3 decimal place lah. Okay, not less than 3 decimal place. But the probability, this one you use 2 decimal place lah, because of this one is integers, right? Okay, now identifying unusual result range rule of thumb. If you still remember, I think we did go through last week about the usual values and unusual values, right? We should have a range of usual values and unusual values. Alamak, I forgot to record. Means that, okay, I just start to record. Sekejap ya. Let me do a recording first. All right. So I only start recorded at slide 18. Okay, now for unusual results. So in this case, we should have a range of usual values. So maksud dia maximum and minimum usual values. So minimum usual values. So this is usual and maximum. So means that we're gonna have a range. So anything falls inside the range is usual values. Okay, anything falls outside the range, we call it unusual. So it is a cases outcome, unusual outcomes. Yeah, unusual outcomes. So how do you calculate this range of usual values or unusual result? Is using this mean plus minus 2 sigma, which is 2 standard deviations. Why 2 standard deviations? Is because according to the range rule of thumb, most values, which is usually most values should lie within 2 standard deviations of the mean. So hence it is plus minus, mean plus minus 2 standard deviations. Yeah. So we're gonna have a usual range in between 2 plus mean mean plus minus 2 standard deviations. So this is the range. This is the range for you to identify whether the outcome is usual or unusual. First, you need to calculate the range. All right. So we look at this example. So we found out that for families with 2 children, the mean number of girls is 1 and the standard deviation is 0.7 girl. Okay, so we know that the mean is 1 and the standard deviation is 0.7. Use those results and the range rule of thumb to find the maximum and minimum usual value. So you need to find maximum and minimum. Based on the result, if the couple has 2 children, is 2 girls unusually high number of girls? Adakah 2 girls? If you get 2 girls, it is unusual. You want to check that. So, first we need to calculate maximum and minimum using the formula where mu mean plus minus 2 sigma. Okay, so mean plus 2 sigma is equal to 2.4. That is maximum value. So the minimum value is negative 0.4. Okay, just substitute into the formula just now. So our range is now, our range for usual value is negative 0.4 to 2.4. And this is the range for usual. So the question is, if the couple have 2 girls, is it unusually high number of girls? So 2 girls, where is 2 located? 2 is located within the range. So means that it is not unusual. Means that 2 falls within the usual values. Means 2 falls within this. Ini perkara biasa lah. It's not unusual. It's usual. So 2 girls is not unusually high number of girls. So that will be your answers. Means that 2 girls is not unusually high numbers. Okay. Very straightforward. You just use the formula. All right. So a rare event rule for inferential statistics. So if under a given assumption, such as the assumption that boys and girls have the same chance of being born, so meaning that kita dah ada assumptions that both boys and girls have the same chance. So it's 0.5 and 0.5, right? The probability of a particular observed event, okay. Contoh, probability of particular observed event, contoh, 879 girls out of 945 births. So what is the probability of getting, we know that probability of getting mentioned here, we assume that boys and girls have the same chance of being born, right? So what is the probability of getting 879 girls out of 945 births, which is too high, right? So the amount of girls out of whom the birth is too high. So the probability is extremely small. Extremely small. It's almost impossible to happen, right? It's almost impossible to happen for us to get 879 girls out from 945 births. Okay, so we conclude that the assumption is probably not correct. Yeah, the assumption that we make that boys and girls have a similar chance of being born might be not correct, right? So now unusually high happens using probabilities to determine when results are unusual. Unusually high happen if X successes among N trials is unusually high number of successes if unusually high if probability of X or more is less than or equal to 0.05. We can say it is unusually high. And we can say it is unusually low if the probability of X or fewer is less or equal to 0.05. We say it unusually low. Okay. Okay, we look at the example here. Okay. Is 879 girls in 945 births are unusually high numbers of girls? Okay. So these are the things that we need to check, yeah? So is 879 girls in 945 births are an unusually high number of girls? So first you need to know what is the probability of getting 879 out from 945. Okay, probability for getting 879 or more girls out from 945 births, the probability is almost zero, because it is too small, because it's quite impossible for you to get 879 girls out from or more out from 945 births. Sorry. Okay, so the probability for getting 879 or more is approximately zero lah, sebab it's too high to get based on the assumptions semua kan, so it's too high. So because the probability of getting 879 or more gold is less than 0.05, is less than 0.05, this one, yeah, this one, because the probability is less than 0.05, we say it is unusually high. So we say it is unusually high number of girls. Okay, so we need to compare the probability with 0.05. If it's less than or equal to 0.05, we say it is unusually high, provided it is X and more lah. If it's X or less, then we say it is unusually low. Betul. Alright? Okay. So far, you guys understand random variables up until unusual and usual and unusual? Okay. Alright. So expected value. Okay. The mean of discrete random variable is theoretical mean outcome for infinitely many trials, right? Okay. The expected value is the average value that would expect to get if the trial could continue indefinitely. Okay, expected value, if you continue doing the experiment, that is the average value, the expected value. Okay, the expected value of the discrete random variables is denoted by E. It represents the mean value of the outcomes, yeah, and it is obtained to find the value of summation of X times Px, which is, when, if you notice, this is actually the formula for mean. Tadi kan, for the probability distribution just now, this is the formula for mean. Alright. So for example, 1,000 tickets are sold at $1 each for a color television valued at $350. What is the expected value of the gain if you purchase one ticket? So if you purchase one ticket, so when you win, you will get 350, right? So when you win, the total untung that you get is 349. Why 49? Because you already pay $1 for the tickets, right? So your gain is 349. Wait, that is when you win. And the probability of winning is, of course, satu je menang kan? So 1/1000 is the probability of winning. Okay. And when you lose, so when you lose, is there any gain? No, but you lose -1 because you bought the ticket $1 kan. So you lost -1. So your gain is -1. And your probability for losing is, of course, out from 1,000, your probability of losing is 999 over 1,000. So you have this probability distribution table here, okay, for x and px. And now you need to calculate the expected value. What is the expected value of the gain if you purchase one ticket? So kira expected value. So this is x and px, yeah, the summation of x and px. So you will have 349 times with the probability 1 over 1,000 plus with -1 times with the probability, which is 999 over 1,000. So you will get your expected value is -0.65. So which means that the expected value of the gain if I purchase one ticket is -0.65. So when you see a negative, your expected value to be negative, so is it worth it for you to buy the tickets? I don't think so, because your, the probability of losing is much higher, and the probability of you to lose your money is much higher. So which is, purchase one ticket, the expected value of gain is actually negative. So sangat-sangat susah nak menang lah, right? Okay, basically that is expected value. So now we look at the second example. The following table is the probability distribution of the number of breakdowns per week for a machine based on past data. So this is your X, this is your PX. Yeah. Ini 0 is no breakdown, 1 breakdown, 2 breakdown per week, and 3 breakdown per week. Yeah. So let X represent a number of breakdowns for a machine during a given week, and Px is of course the probability. Find the expected value of the number of breakdown per week for this machine. So what you do is you expand the table to find X times Px, because you know that is the formula for expected value. So the summation of X times Px is equal to 1.8. which is the expected value. So we can say that on average, this machine is expected to break down around 1.8 times per week over a period of time. Okay? Senang je kan? Okay, now we go into binomial probability distributions. Yeah. So in this section, we're going to look into a basic concept of binomial distributions, the notation that we're going to use, and methods for finding probability values. And binomial probability distribution allow us to deal with circumstances in which the outcomes belong to two relevant categories, such as acceptable, defective, survived, died, successful, unsuccessful, macam tu lah. Dia mesti ada two relevant categories. That is binomial probability. Okay, this is the requirement for using binomial probability distributions. Yeah. So the requirement is the first one. The procedure has a fixed number of trials. So number of trials have to be fixed. Yeah, that's the first requirement. The second requirement, that the trial must be independent. Must be independent means that the outcome does not depend on the other trials. So dia memang independent, yeah. So does not affect each other. And each trial must have all outcome classified into two categories. Ini yang kita cakap tadi, into two categories. It's either defective, undefective, success, failure. There must be two categories, must be classified into two categories. Yeah. And then the last one, the probability of success must remain the same in all trial. Probability of success must be the same in all trial. So these are four requirements for you to use binomial probability distributions. Yeah, we look into it. So these are some of the notations that we're going to use in binomial probability distribution. Okay, S and F is success and failure. Two possible, and then this is the probability for success. Probability for success is P, Yeah, and probability for failure is of course 1 minus P, so we can call it Q. Okay, this is probability of success, probability of failure. Okay, they are complement with each other. Probability of failure is 1 minus probability of success. Yeah, N is the number of trials, fixed trial, because this is binomial probability. X is the specific number of success in n trial, specific number of success in n trials. So X can be any whole number between 0 and n. Okay. P denotes the probability of success. Q denotes probability of failure. And Px is the probability of getting exactly X success among n trials. Yeah. Okay, this is the formula for probability binomial probability formula. So probability for getting exactly X equals to R is we use this formula here. Okay, remember N is the number of trials. R is the number of success. R is the number of success among trials. P is the probability of success. Q is probability of failure. Okay, so you don't have to remember the formula lah, but this is the formula for the binomial probability. Okay. Okay, this is the same formula, I believe. Yeah, it's the same formula. Okay. All right, we look at the example of binomial. So given that there is 0.85 probability that a randomly selected adult know that what Twitter is. Okay, 0.85 probability adult knows what Twitter is. So that will be our success category. So 0.85 knows what is Twitter. So our P, probability of success, because they know, probability of knowing Twitter is 0.85. So by that, we know that probability of not knowing what Twitter is 0.15. How do we get 0.15? It's 1 minus 0.85. Okay, that is our Q. So we have that. Use the binomial probability formula to find probability of getting exactly 3. So we want to find P x equal to 3, probability of x equal to 3. Who know the Twitter is when 5 adults. So our n is equal to 5. Our 5 adults are randomly selected. So we want to find P x equal to 3, and these are all the data that we have from the questions. Yeah, R is 3 lah. Sebab tadi kan, this is R, right? R is 3. So what you need to do is you just substitute all the values, all of the data here into the formula for the binomial just now. Okay, you substitute it in, you calculate the factorial semua, calculate, and you will get 0.138. So very straightforward. So you just need to extract all the information from the questions. Dapat information, tahu apa yang question tu nak, then you just choose which formula to use. Know what the questions want and which formula to use, then you just calculate. Mention 2. All right, so the probability is 0.138. Okay, that is binomial. So now also we also have a formula for mean, variance, and deviation for binomial distributions. Kita ada formula lain juga for the mean, variance, and standard deviations. So these are the formula. Okay, this one just now, this is what we have learned previously for discrete probability distributions. Yeah, kan? This one is for the binomial distribution. For the mean is n times p, very straightforward lah. N times p, variance is n times p times q. Standard deviation is square root of course, n times p times q. Okay, so this is the formula for binomial distribution. So in cases where the question wants you to find mean, variance, and standard deviation for binomial distribution, then you just use this formula here. Okay. So look at the example. Ini example just nak tunjuk lah how are you going to use the formula. Okay. The brand name of McDonald's has a 95% recognition rate. Okay. So the brand name of McDonald's has a 95% recognition rate. So the success rate is 0.95 lah. So our P is 0.95. We know from that already. So kalau kita tahu P, we know our Q of course. So just 1 minus 0.95. A special a special focus group consists of 12 randomly selected. So our N is 12. Our N is 12. To be used to extensive market testing. For such random group of 12, find the mean and standard deviations for the number of people who recognize brand name of McDonald's. So we know our Q, we know our P, we know N, we know P, we know Q. So we can calculate the mean and the standard deviations. Kan? So the mean is N times P. So you just calculate. And the standard deviation is square root N times P times Q. Calculate. You get 0.8. Jadi senang je kan? Semua boleh dapat A. Alright, this one. Also example for you to calculate lah. Okay, so from the from the question, you just extract the data lah. Huh? So 56% of teens in United States volunteer times for charitable causes. Okay. Assume that this result is true. So our P 56%, so our P is 0.56, our Q is 0.44, satu tolak 0.56. A sample of 60, so our N is 60. So we want to find, what is it? Mean and standard deviations. So mean is NP, Q, standard deviation is square root of NPQ. So you substitute je and you calculate and you will get your answers for mean and standard deviation. Okay. Now, the range rule of thumb for binomial. Okay, so the formula is the same. Must be mean plus minus 2 standard deviations. Yeah, this is the rule of thumb, the unusual and usual values. Okay. Okay, look at this example. So from the previous example, you have 12 randomly selected people. The mean number of people who recognize the number of McDonald's is 11.4. Okay, the mean is 11.4. The standard deviation is 0.8. So for groups of 12 randomly selected people, use the range of thumb to find the minimum usual number and the maximum usual number. Okay, you can cari minimum and the maximum, which is using this formula, plus minus 2 standard deviations. In one particular randomly selected group of 12 is 12 and an unusually high number of people who recognize the brand name of McDonald's. So first, before you can answer B, you have to calculate A first. You calculate A, plus minus 2, you added 13 and 9.8. So your range is 9.8. Your usual range is 9.8 to 13. Okay. And soalan B tanya, is 12 is a usually high number of people who recognize the brand number of McDonald's. So 12 falls within the range, right? 12 falls between 9.8 and 13. So since 12 falls within the range of usual values, we conclude that 12 is not unusually high number. Sebab dia falls within the range and the range is usual range. Okay, so 12 is not unusually high number of people who recognize the brand name of McDonald's. Okay, senang kan? Tadi je senang kan? Okay, our last part of today's lecture, which is Poisson probability distributions. So this is the last part where sebelum kita cuti raya. Right? So Poisson probability distributions. So look at this one. Okay, definitions of Poisson distributions. So it is a discrete probability distribution. Semua ni discrete distribution lah. Binomial is of course also a discrete distribution that applies to occurrence of some event of a specified interval. The random variable x, then for r 0 to n, the number of occurrence of the even in the interval. The interval can be time, distance, area, volume, or some familiar unit. So this is the formula for probability for Poisson distributions. Tadi binomial lain kan, but this is the Poisson. After this, I'll show you the requirement of Poisson probability distributions. Yeah. So this is the requirement of Poisson probability distributions. First, the random variable x is the number of occurrence of an event over some interval. Okay, the random variable x is the number of occurrence of an event over some interval. Dia mesti ada interval ya. Macam for 1 week, for 2 weeks, dia mesti ada interval. Second one is the occurrence must be random. Dia mesti random. Okay, mesti random, it must be random and it must be independent of each other. So means that the occurrence have to be random. Usually random is something like when you want to talk about the number of death in your kampung, the number of death in your kampung in like 1 week. Macam in 1 week, how many deaths happen? So death is something that is random, right? We don't know when death happen. Very, very random. Kita tak tahu yang today berapa orang, esok berapa orang. So it's very random and it's very independent. Independent for each other. So it doesn't mean that today we have 1 death and tomorrow we also have 1 death. Sometimes we don't have death at all. Macam itulah. The occurrence must be uniformly distributed over the interval being used. Okay, the mean is we call mu. The formula for mean we use mu. And then the standard deviation is, the formula for standard deviation is the square root of the mean. Okay, the square root of the mean. Okay, this example of Poisson probability distribution. We can apply the Poisson probability distribution in this kind of example. For example, number 1, number of accidents occur on a given highway during 1 week period. It's very random, right? We don't know when accidents happen. It's very independent. See? And then the second one is number of customers entering a grocery store during 1 hour interval. Also random, also independent. And number 3, and also the other interval, right? Poisson probability must have interval. So for example, the number 1 is now is 1 week period, and number 2 is 1 hour interval. And number 3, the number of television sets sold at a department store during a given week. Dia punya interval is week, and the number of television sets sold, that is very random. We don't know how sama ada hari ni kita jual 2, esok kita jual 3. We don't know. It's very random and very independent. Yeah. So you have to be random, independent, and ada interval. Okay. So the difference from binomial distributions. So first, the binomial distribution is affected by sample size n and probability p, whereas the Poisson distribution is affected only by mean, because we don't have probability, right? Because it's random, it is independent, so we don't have probability. So it does not affect any of our distributions for Poisson. In binomial distribution, the possible values of the random variable x is 0, 1, and n. But a Poisson distribution has possible x values of 0, 1, 2, and we don't have any limits for the Poisson distribution x values. We don't have any limits, yeah, because it's random, right? We don't know how many and what is the maximum and what is the minimum. That's the difference between binomial and Poisson. Okay, now look at the example. On average, a household receives 9.5 telemarketing phone calls per week. 9.5 phone calls per week. So we have interval, right? And we're talking about phone calls. So we don't know, phone calls is very random and also independent. So using the Poisson probability distribution formula, find the probability that a randomly selected household receives exactly 6. Exactly 6. So we want to find probability for getting exactly 6 phone calls during a given week. So what you need to do is you just substitute into the formula for yang ini tadi lah, yang awal tadi. This one. You just substitute into the formula probability distribution for poison. Okay, so you just substitute into that and you just calculate. Ini apa?
Exponent.
Exponent, betul. Don't tell me you don't know what E is, huh?
Proof.
Okay. Now, another example. So for a recent period of 100 years, okay, ada interval kan, 100 years, there are 93 major earthquakes in the world. Assume that the Poisson distribution is suitable model. Okay, find the mean number of major earthquake per year. Okay, that's A. So find the mean number. So the mean is of course given to you is 93 earthquake. So we didn't have 100 years. So our mean is 0.93. Okay. If Px equals to R is the probability of R earthquake in a randomly selected year, find P0, P1, P2 until P7. So you need to calculate for probability up until P7. So using formula, you need to use the formula. You need to substitute into the formula. You get these answers. Ni dah kira lah ni. Okay. So you can try on your own later. This one is already calculated using the Poisson formula. Okay, now this is the one that we calculate. Yeah, B is the one that we calculate. Now, given in C, they give us the actual result of the earthquake. So 47 years, 0 earthquake. 13 years, 2 major earthquakes. 5 years, 3 major earthquake. 2 years, 4 major earthquake. 0 years, 5 major earthquake. 1 year, 6 major earthquake. And 1 year, 7 major earthquakes. So how do this actual result compare to the probability found in B? So zero major earthquake, the probability is now, this is the usual one, the actual one, the probability is 0.47, 0.13 up until 0.01. So they want us to compare with the one that we calculate using Poisson distribution. So when you compare like 0, okay, P0, this one is P0, P0, 0.47 and 0.395, dia tak jauh kan? Okay, dia tak jauh. So when you compare 0 earthquake, 0.47 and 0.35, dia tak jauh. Okay, and when you compare 2, for example, is 0.13. So for when you calculate, we get 0.17. Tak jauh kan? And then also when you look into the number 6, for example, 6, P6 0.01 and 0.02, of course, lebih kurang lah kan? And 5 earthquake, which is P5, 0.002, which is equal to 0. The actual one is 0, so tak jauh. So the value obtained from the model, so this is the value that we obtained from model, B we obtained it from model, are quite close to the actual data. When you compare one by one, it's quite close to actual data. Yeah. So does the Poisson, the last one, does the Poisson distribution appear to be a good model in this case? So does the does the Poisson distribution is a good model for this case? In this case, the answer would be yes, because when you compare the one that you calculate using the Poisson model and you compare with the actual cases, it is almost similar. So means that this Poisson distribution is a good model to use for these situations. Why? Why is it a good model? Because we compare tadi dia hampir sama. It's because when you look at the situations, it has an interval of 100 years. That is requirement, also one requirement in Poisson distribution kan. And it has to be, the occurrence have to be random and independent. So earthquake is very random. We don't know when it happens, and it's very independent kan. We don't know bila dia tak, today might not be happen, hari ni this year tak happen, next year maybe happen. So it is very independent. That does not affect each other kan. So that's why we believe that it is a good Poisson distribution will be a good model to to be used in this type of situations. All right, based on the requirement. All right. So example, the last example, I believe, an auto salesperson sells an average of 0.9 cars per day. Let X be the number of cars sold by this salesperson on any given day. Using the Poisson distribution table, find the probability that the salesperson sells more than one car in a day. Okay, so the probability for getting sell more than one car. So macam mana you nak kira ni guna Poisson? Is of course you want anything, you want probability that is more than one. So means that you know the summation of probability is equal to 1, right? So 1 have to minus anything less than 1. So 1 have to minus probability of getting 0 and probability for getting 1, because we only want probability for getting more than 1. So that's why 1 minus p x equal to 0 minus p x equals to 1. So once we know this, we just substitute into the formula, buat satu-satu, and you get the probability for getting more than one cells in a day is 0.227. Okay, and then write the probability distribution for x of x. So write the probability distributions of x. So what you do is you just kira lah for x equal to 2, x equal to 3, x equal to 5, 6, and all. Okay, once you have everything, when you plus it together, you will have equal to 1. Sebab why? The summation of probability distribution have to be equal to 1. Habis. Dah. Any question?
One confirmation, Doctor, I need.
Yes.
Our midterm examinations will be until chapter 6 or 5?
Oh, no. It's only linear algebra part. So we'll be learning unit 1 until learning unit 4.
Oh, okay.
Yeah, until eigenvalues and eigenvectors.
Oh, okay. Thank you, Doctor.
All right. And for our final, it will be on statistics part. So the first part, the midterm test, it will be the linear algebra part. So we will cover all the linear algebra. And for the final, we do not cover linear algebra anymore. So final only focus on statistics. So maksud dia chapter 5 until chapter 11 that will be in finals. Any other question? MCQs, we have, I think I've written this in our main page. We have 40 questions MCQ. We have 40 question MCQ, and we have 4 questions in section B, which is structured questions, section B. If you want more details information, you can look into the main page of our course lah. Dekat situ saya ada letak all the details on our midterm test. From what time to what time. All right, any more other questions before we stop?
No, madam. I think that is all.
All right. Okay, now thank you everyone. So selamat Hari Raya. Happy holiday to everyone.
Thank you, madam. Selamat Hari Raya
Thank you, madam. Selamat Hari Raya.
Thank you, madam. Selamat Hari Raya.
Thank you, madam.
Can you
Madam,
QR code?
I cannot scan. We have to scan attendance.
No, we don't have QR code today. Still have problems.
Oh, okay. Thank you.